Test on fresh concrete by compaction factor. At the end of this lesson, you will be able to define compaction factor, demonstrate the test on fresh concrete by compaction factor, explain the advantages and disadvantages of compaction factor test. We all would have performed this activity at our home, that is, filling up a container. Assume that you are trying to transfer the grains from the rice bag to a container. You lift the bag and place it close to the mouth of the container and allow the rice to fall into the container. After filling 3/4 of the container, you will try to compact the filled rice by shaking the container, won't you? In the same situation, what if the rice is poured into the container from a particular height? While falling from a certain height, the grains get compacted internally due to the gravitational force applied. Then, you shake the container externally. When you compare both the conditions, external energy for the first condition is more than the second condition. Do you know the reason for this? It is because the grains that fall from a certain height get compacted internally, and then you shake the container externally. Likewise, when the concrete is made to fall from a certain height, concrete gets compacted internally and then a lesser amount of external force is applied to compact the remaining concrete. Thus, its compaction efficiency will be more. The test which considers this factor is called as compaction factor test. Slump cone test is generally used for determining the workability of highly workable concrete, whereas compaction factor test is used for determining the workability of less workable concrete. Now, let us discuss about the compaction factor test in detail. As per IS 1199-1959, compaction factor test apparatus consists of two conical hoppers and a bottom cylinder. The inner surface of the conical hoppers is smooth and attached to the trapdoors. The upper hopper's top internal diameter is 254 mm. Bottom internal diameter is 127 mm and internal height is 279 mm. The lower hopper's top internal diameter is 229 mm. Bottom internal diameter is 127 mm and internal height is 229 mm. The vertical distance between the two hoppers is 203 mm. The bottom cylinder's internal diameter is 152 mm and internal height is 305 mm. The vertical distance between the lower hopper and bottom cylinder is 203 mm. Apart from that, a tamping rod of size 16 mm in diameter and 610 mm in length is used to compact the concrete. For example, let's take M15 grade concrete. Prepare the mix using 1 part of cement, 2 parts of fine aggregates, and 4 parts of coarse aggregates. The water content is calculated based on the water-cement ratio, generally varying from 0.4 to 0.6. Now, mix the fresh concrete. The inner surface of the hoppers and the cylinder is made free from moisture and greased. Close the trapdoors of the hoppers. Then, measure the empty weight of the cylinder, that is W1 kilograms. Fill the fresh concrete on the top hopper using a trowel without compacting it. Then, the top hopper trapdoor is opened. Thus, the concrete falls on the lower hopper. Gentle tapping is done using a tapping rod to push the remaining concrete from the top hopper to the bottom hopper. When all the concrete has fallen on the bottom hopper, remove the bottom hopper's trapdoor and let the concrete fall into the cylinder. When the bottom cylinder is filled with concrete, remove the excess concrete from the top of the cylinder using the trowel. Then clean the sides of the cylinder properly. Then measure the weight of the cylinder with partially compacted concrete, that is W2 kilograms. Then the cylinder is emptied and the concrete sample is filled again by filling it in 3 layers. Each layer is compacted by giving 25 blows using the tamping rod. Now, the concrete inside the cylinder is fully compacted. The weight of the cylinder with fully compacted concrete is taken as W3 kilograms. Compaction factor is determined using a formula, which is the ratio of weight of partially compacted concrete to the weight of fully compacted concrete. That is, the ratio of W2 minus W1 to W3 minus W1. The value of compaction factor varies from 0.7 to 0.95 based on the workability of concrete. The major advantage of the compaction factor test is it is used to calculate the workability of concrete with low water-cement ratio. And the limitations of this test are it is suitable only in the laboratory, and the apparatus and maintenance cost is comparatively high. Summary: compaction factor test is used for determining the workability of less workable concrete. Compaction